talk, we're going to be taking a look at some of the tools that we can use for working with Excel as Java. But quickly to introduce myself, I'm Tony Roberts. I worked in finance as a developer for many years, both on the buy side and sell side for hedge funds and banks and things like that. And as some of you may know, that's an industry that really runs on spreadsheets. A few years back, I launched a product called Jinx, and that's for developers to write Excel add-ins using any JVM language. Today we're going to be looking at Java, but the same applies for Scala, Kotlin, Enclosure, and all of that. So I just want to start by sharing my screen. So I'm going to take the camera off for a second. And hopefully you're still with me and can see the screen. Yeah, looks good. Okay, so as I said, this is me, Tony Roberts, developer of Jinx, and the email address here, tony@exceljava.com. If you want to get hold of me afterwards, then feel free to email me at that, and the website is exceljava.com here. I'm just waiting to hear that you can see my screen before I continue. Okay, great. So first of all, as developers, you may be asking why Excel, because it's often easy to dismiss Excel as something that we don't need to care about. Many of you will have been burnt in the past by users creating overly complex or magic spreadsheets that are just impossible to maintain or support. And so it's kind of understandable that now you may want to avoid having anything to do with Excel whatsoever. And actually, I remember when I first started working as a developer for a hedge fund, I worked on this application for the traders to use. And I was really pleased with how it turned out. But the first time I demoed it to the traders, so these are the guys who would be using this new application that I built, literally the very first question I got was, how do I export this to Excel? And it's vital for us to remember that our role as developers is to build software that benefits the business. And very often that means that a human end user is involved. And those users that we're supporting, more than likely in some capacity or another, are going to be using Excel. So what I really want to get across to you in this talk is that working with Excel doesn't have to mean writing or maintaining VBA or complex spreadsheets. And there are tools out there that make it really super easy to bridge that gap between us as Java developers and Excel as a user interface tool. And if you only take away one thing from this talk today, I'd really like it to be that working with Excel and Java can actually be pretty fun. Now, what I want you to think about really is Excel as another front end. And whenever we're building something that will have a real end user, we have to make decisions about how that end user will interact with whatever it is that we're building. That's what I mean here by front end, and that's how the user experiences all of our hard work in the back end. Now, if we get this front end wrong, the user will be unhappy, regardless of how good the back end that we've built is. So one option that a lot of you will be familiar with is building out a desktop application. So we could build out a desktop application using JavaFX or Swing or any of the other windowing toolkits. These can result in a really great user experience. And using one of these toolkits, can give us complete control of what the user sees and can do. But it can be pretty complex and time-consuming to write. So another option, which is really popular these days, is to write a web app, and we can do that with JSP or something like that. And I think that's something that everyone will be familiar with, and certainly users now are very used to consuming applications written as web apps. Often you can find this requires some specialist expertise, and it may even involve bringing in a separate web team to develop. So in both desktop applications and web apps, what the user sees is it's pretty fixed. if they want to move stuff around or do some extra analytics or reporting, then that involves them coming back to the developers with more requirements and then spending more development time building out the app. And often what you'll find is the way that they get around this is by having just one button to export everything to a CSV file, something like that. And then once they've got it in Excel, then they can do what they want. And really, that's what I was saying at the beginning, where when I built this whole app out, the traders' first question I had was, okay, great, how do I export this to Excel? For many use cases, when we're building out a desktop application or a web app, it's really easy to get carried away implementing more and more complex user controls, things like that, and grid controls and stuff to try and keep the user inside our user interface, because we really don't want them to be just using our interface to copy and paste to Excel. So we try and make the application as attractive as possible. But what if we could think about this kind of the other way around? And what if we could use Excel in the same way that we use a web browser, and just as the presentation layer on top of our back-end code? And again, I'm not talking about writing loads of complex VBA code here. What I want to show you next is just a few different ways that we can use Excel as a front end using only Java code without requiring any VBA. And there's a few different options for how we can work with Excel from Java. Now, none of these options I'm going to show you are particularly scary, and it's worth knowing about all of them so that you can choose what's right for your specific needs. And the first is perhaps the simplest, kind of conceptually at least, and that's just reading and writing Excel files for static reporting. The second thing I want to show you is how to automate Excel from a separate Java application. This gives us a bit more flexibility to create interactive applications rather than just static reports. And then finally, the last option that we'll look at is writing an Excel add-in in Java. And this is by far the most integrated way for us to use Excel as a front end for our Java applications. Now, excuse me. To begin with, writing static Excel reports. This is something you may be familiar with already. Often we need to output a report from some system or another. More than often that might just be a plain text file or a CSV file. But if that report is going to be used by an actual person, we can be pretty sure that they're going to use Excel to read that. So next, imagine that part of your job was to take a CSV report, export it from some systems, do some calculations on the data, get some summary level results, that kind of thing, and then produce a report for higher level management, something like that. And that's actually a very simple way of describing what a lot of people spend a lot of time doing. So we can save the end users a lot of time and frustration by actually giving them a report that's formatted in a way that works for them, rather than just a CSV report. And there's various other things we can do as well to make their lives easier, like we can include multiple sheets in one document so they're not constantly having to flick between and try and cross-reference data between documents. We can even include formulas for basic calculations. So if they have common tasks where they load in some data, do some quick analysis, that kind of stuff, we can do that for them in an Excel file. We can even go crazy with charts and formatting and produce completely finished reports just directly from Java. So given that we can do all of this from Java, how much better is it that we can give users reports in a way that works for them, rather than have them load a CSV file or load a bunch of CSV files, combine them together, write a load of VBA to automate stuff. This is a much better way for companies to work. And it turns out that there's a really great package for writing Excel reports from Java, and that's Apache Poi. And that's what I want to show you in this first demo. So if you don't already know about this package, it's well worth looking into. It does way more than what I'm going to cover today, including reading Excel files and other Office files, as well as writing them. But we'll have a quick look now about how we can generate Excel reports instead of CSV reports. So let me just come out of PowerPoint. And yeah. So what I've got in this kind of example, and again, this source code is all online, so there's no need to make notes now or anything. You can download it later. But what I've got in this file is just a main function which is loading in some data from a CSV file. So this is really to simulate what we might do if we were using a database. So here I've just got some simple data in a CSV file that you might be calculating, or you might be loading from a database, or whatever it is. And I'm using Apache Poi to create a new workbook object. In that workbook object, creating a new sheet, and then writing those records to the sheet. So inside this write basic report method here, we're creating a header row and then just simply writing the records, just iterating over the rows and writing the cell values. So if I run this now, hopefully if I've got this right, there we go. So it's now saved a new Excel workbook here. If I open that, we can see we've got the same data that I had in that CSV file, but now written as an Excel file. I still have to go in and change the size, and nothing's formatted nicely. So really, at the moment, we don't have any benefit over doing a CSV file, but we've written something out in an Excel file. So I'll close that now.
Hey Tony.
Hi.
Can you please increase the resolution of your screen or
Sure.
editor?
Is that better or more?
Maybe a bit more.
A little bit more. Okay. Let's try. How's that?
Yeah, let's see. Let's check that.
Great, thank you. Okay, great. So now we've seen how to write out a very basic report. I want to show you how we can do a little bit more. So in this second method I've got here, I'm basically doing exactly the same thing, but rather than just writing the values for each cell, I'm also, here I'm setting the values, but I'm also setting a cell style for some of these. So here you can see on one of the columns, I'm setting a style, this amount style, where the amount style I've created earlier, and I've given it a specific format of how to do that. And we'll see in some other cells as well, I've got like a header style here, which is a different color, and I've got a percentage style here, which is going to show numbers as a percent. So if I run this one now, there we go, save the workbook again. And now when I open it, we've now got something that kind of looks a lot more, a lot better for the user that's opening up this file. So just with the small change, we've already made their lives just slightly easier. Now, the last thing I wanted to show you here, I'm not going to spend too much time looking at Apache Poi. Like I said, like this code, I've got this third method, write formatted report with sums, and this is doing the same thing as writing the formatted workbook that we had before. But what we'll do now is add an extra row, which adds a formula to the bottom. So I've got a bunch of stuff here, which is saying create a new cell below the last row, and then just set the cell formula using this set cell formula method. And if I run this one, save the workbook again, and so now we've got the same formatting as before, but here we've actually got formulas. So these aren't pre-calculated numbers. This is actually an Excel formula that's summing these columns. So hopefully here, we haven't looked at the code in too much detail, but this is really just to give you an idea that rather than just outputting CSV files, we can output stuff which is immediately useful to the end user, and also give them some kind of stuff so that, if they wanted an interactive report where maybe there was a few blanks that they could fill in, we could give them some formulas so they can do some basic analysis without having to go back into a different application. So with that, I just want to jump back into PowerPoint. And the next thing I wanted to talk about was actually getting closer to what we said about using Excel as a front end, and that's automating Excel, because writing out Excel reports is great, but as we can see, there are some limitations. So the user might be able to request that a report gets rerun, but at the end of the day, it's still just a more or less a static report. So Excel is used for much more than just a tool for viewing static reports. Really, it's an insanely flexible UI tool disguised as a spreadsheet. Now, traditionally, Excel is automated or scripted using VBA. But just imagine for a moment that instead of writing VBA in an Excel spreadsheet, we can instead do all the same things, but with a Java application in control, using Excel as a really user-friendly front end. And in fact, we can. So anything that we can do in VBA can be done just as easily in Java, or in fact, any language. Now, the technology that we use to do this is COM. There's probably a few of you that are having a bit of a heart attack now because, well, COM's a pretty ancient Microsoft technology, but despite its age, it's still widely used by Windows applications. Now, it's kind of notoriously difficult to work with, but I think most of that stems from the intricacies of dealing with COM interfaces from C and C++ code, and that's where traditionally COM was mostly used, and that's, I think, why it has this reputation of being so hard to work with, just because from C and C++ it is hard to work with. But using Java, COM is much simpler than you may realize, and it's really not that scary at all. Once you've got over the shock of COM, then you'll find that the entire Excel VBA class model is exposed, meaning your Java code can interact with Excel just as easily as if you're writing VBA. Now, there are a few different Java COM bridges out there, but the one that I found that works really well is Com4j. Before you start calling COM interfaces with Java using Com4j, you need to generate these Java wrapper classes. That can be a bit fiddly, especially if you're not familiar with COM already. But for Excel, there's no need to do that because you can just pick up some pre-built wrapper classes from this Excel Java repo here. So if you go to the Excel Java organization on GitHub and find Jinx Com4j, you'll find everything you need to get started with Com4j and Java. So I want to jump into another demo now to show you how this works. Hopefully we'll see. So what I've got in this example project is, again, another main class. And here we're getting this application object. Now, this application object is identical to the application object that you'd use in VBA, but instead of VBA, obviously we're doing it in Java. So I use the Com4j package here to get an active object. That's the sort of terminology for the COM object. And in order to know what object I get, I have to give it this class ID. So this class ID here is just this hard-coded identifier, but this is the identifier for the Excel application object. So once I've got this application object, I want to show you a really simple example, which is just getting the current selection and then setting the value of that selection. So here, this Excel is my application object. I'm getting the selection method. And then this query interface, again, this is another bit of COM terminology, but really this is like a cast in Java. So we're getting the selection as a generic COM object, but then calling query interface to get the range interface to that object. And once we've got the range interface, we can select the value here. So if I show this side by side with Excel, then if I select some things here and then run this code, hopefully, yeah, there we go, you see. So I've now set everything in the selection to hello. Let's just run that again for a single cell. And there we go. So we can see we can actually script Excel using Java kind of in the same way as we could using VBA. Now, I want to show you a very kind of another example, but a bit more of a real world use case. So as I spent a long time working in finance, I'm going to do a sort of financy type example, but hopefully it shouldn't be too hard to follow. Now, in a lot of trading firms, the way they work is you'll have traders on the phone to brokers or counterparties doing trades. They might be using Excel to calculate exactly what the trades are they want to do. They'll have some analytics where they're doing what they call like pre-trade analysis. They'll then execute the trade, and then they need to actually execute. They need to actually record what they've executed into some system for keeping the trades for that day. Now, the way this used to happen is that traders used to actually have a paper blotter, and they'd write down what they'd done, and then at the end of the day, a trading assistant would come and collect all those paper blotters and then spend a few hours entering them into a system. Today, things are done a bit more real time than that. So often traders will have another system on their screen that they'll use to enter them. But still, they're copying and pasting values from Excel. So there's errors come in. If we can give them the same thing but in Excel, then that's a big advantage. So here I've got a method called write trade blotter. If I run this, what we'll see here is that it's just writing some headers. So this is just setting these values and then setting the style in the same way that we could from VBA. So this is giving the trader this trading blotter where they can say, okay, I traded this, I traded 100 of those, I traded at 5, and I also did these, and price was 45. Now, the other side of this is give them another thing called read trade blotter. And this is what this is doing. And this is what and then this is where it would connect directly to the trade booking system, save them to a database, whatever it is, but all without the trader having to come out of Excel. So if we run that now, we should see, yeah. So now they're getting some feedback saying this one's been booked, but this one there's an error. So it's saying the price must be greater than 0. So here the trader gets that instant feedback rather than writing it on a paper blotter and then the next day someone saying, oh, like I couldn't read your handwriting on, and the next day someone saying, oh, like I couldn't read your handwriting on here. They're getting this instant feedback saying actually that should have been 45. Run it again, and now both trades are booked. But also because it's all in Excel, they haven't had to come out to copy and paste values from one system to another. They've just been able to do it all entirely with Excel. Here I've been running this code using just IntelliJ, but you can imagine if you were writing a desktop application, then you could have buttons and controls within that application that would then script Excel in the same way that I've shown here. Okay, so back to PowerPoint. What I want to talk about next is kind of this is really where we get to the point of being able to use Excel as the front end. So we've seen how we can output stuff to Excel and how we can interact with Excel from a separate application. But really, we can do way better than that, because if our users are already working in Excel, then why make them come out to use an external application, export some data or whatever, and then go back into Excel? That's it's a lot of wasted time for them both, and it's also a lot of time for us building out complex user interfaces that aren't really what the user wants anyway. So what I want to show you next is that we can actually build our application, or at least like a large part of our application, to run right inside Excel. And I'm not talking about writing loads of VBA glue code or anything like that. What I'm talking about is writing an Excel add-in entirely in Java, using the same Java tools that we already use, and then deploying that code through Excel. But rather than being like code that's stuck in an Excel workbook, it's still building out as jars, still deployed from a central location. So we can still do unit testing, we can still use version control, all of that kind of stuff that we just can't do with VBA alone. Now, for a long time, to write an Excel add-in, there are only a few limited choices. You could write it in C or C++, or you could write it in VBA or C#. And for many enterprise solutions, C# was kind of the least worst choice, as there was no good way to write an Excel add-in in Java. Now, I've had quite a bit of experience with this, and actually, I guess like more than 10 years ago now, I launched a product called Pixel, which was a tool for building Excel add-ins in Python. And then a few years ago, I was talking to various people about the difficulties that they'd had using Excel in their organizations. And they said that basically they hadn't come across anything that could bridge Java and Excel in the same way that Pixel bridged Excel and Python. And I did some research and realized that there really wasn't anything available that was, anything decent that worked for Java. So I kind of took it upon myself and launched Jinx, or Java in Excel. So I launched this a few years ago now, but having developed Pixel and having that being used by sort of large companies for over 10 years gave me a massive head start. And the two products share a common code base. So right from the first release, it was super stable and super reliable. Now, with Jinx, you can write fully featured Excel add-ins in any Java or JVM language. And that can be used to expose new Excel functions to users or worksheet functions, stream real-time data as RTD functions, write macros, menus, etc., that kind of thing. And even, in fact, pass Java objects between Excel functions, and I'll try and include that in the demo just in a second. So, first of all, I wanted to show you just, before we jump into the demo, just a very simple example of what an Excel function looks like. So here on the left-hand side, I've got this static Java method calculating Fibonacci. Like if you've ever done a job interview, then you've probably written this code. And on the right-hand side, calling the same thing, but from Excel. And you'll see the magic thing here is this Excel function annotation on the Java method. And that's what I want to show kind of in a demo now. So, yeah. So what I've got in this example is, first of all, let me just show you. If you go to this exceljava.com website, you'll find kind of everything you need to know about the Jinx add-in, including there's documentation for Java and some other languages and all this stuff. And then also there's a download page where you can go and download the add-in for yourself. Once you've downloaded it in Excel, you can just, in options, add-ins, if you've ever used an Excel add-in before, then it's exactly the same here. You just go and add the add-in that you've downloaded as a new add-in, and then that adds it to Excel. And then there's a config file for the add-in itself. So here in this config file, one of the things that you configure is the Java class path. So here I've got it configured to use a jar which I'm building from this project, and then you can also give it a list of classes to load. You can also, in this example, I've actually got a list of classes as a text file here, which gets included as a resource. But again, this is kind of covered in the documentation. I just want to show you how it works at a slightly higher level. So with this class here, this Excel functions, I haven't got anything in it at the moment. But if I add, let's just say public static method that returns double, let's just call a function called Java tests. And oops. This kind of thing. So you can imagine this could be, whatever function you want to write, and it's just running as normal Java using whichever JVM you choose. So I think I'm using the OpenJDK 14, but you can select in the config file what JVM you use, so you're not limited there. And here I'll just return, I don't know, something super simple like that. So I'm just multiplying the first two together, adding the third, and returning it. So nothing too special now. Now to add this function to Excel, all I have to do is add this Excel function annotation. And if I build this jar now, That's finished. What we can now do in Excel, reload the Jinx add-in, and then now we've got this Java test thing here. So it was 1 times 2 plus 3 gives us 5, and that's actually running our Java code here. And we can even see, if I just put them side by side again, if I can do that. I can even set a breakpoint here, and then using the Java debugger, just connect to here, and then now when I run this this Excel function, it's now stepping through, and I'm in my IntelliJ IDE seeing all the parameters that are being passed through here. So now I can really develop Excel functions, but entirely in Java. Now I wanted to show you an example of a slightly more complex function. So again, apologies, this is another finance example. But if you don't know, if you know about finance, you've probably come across this Black-Scholes formula. But if you haven't, don't worry too much. Just think of it as a kind of a complicated maths function. But what it will do is give us the theoretical value of an option. So we can see here in this Java code, I've got a bunch of inputs. I'm doing some calculations here on those inputs, and I'm returning, the value here. Again, it doesn't really matter too much what it is. But the inputs, let's say spot price would be 100, so that's the price of like our stock that we're looking at. Strike price is the strike price of the option. Again, I won't go into too much details. Just put some values in for these things. This sort of thing. So these will correspond to these things here. And if I do Black-Scholes, put these values in, and there we go. So again, I could put a breakpoint here, see exactly what's going on, see the options that are being passed in, and go through and debug my code that way. So you may sort of say at this point, like, so what? That's just one function. But really, what this allows us to do is build like dashboards and things in Excel. And if I open up this sheet that I had before, what this is using the same function, this Black-Scholes function, with a bunch of different inputs, calculating the things and then plotting something. So, if we were working in a bank and they said, okay, we need an option calculator for calculating a portfolio of options for pre-trade analysis, this kind of thing. Sure, we could go ahead and we could build like a JavaFX or a web app to do that. But then those requirements would change probably, before we'd even finished doing it. Doing it this way, we provide a well-tested, unit-tested function to do that. And then we can give that to the front office, the traders, as like a toolkit. So we can have like a number of these functions where then they can build their own sheets, and then they're in control of kind of how they use that function that we've given them. So here, for example, you can see I've got a bunch of calculations. I could say, okay, what happens to this curve if I change this its call option to false? Oops, I've still got a breakpoint. But there we go. We can instantly see this kind of stuff, and this is what what we might want to build into a user interface tool. But in Excel, we've just got such a massive head start because of all the UI stuff that it's given us already. So volatility was changed from 15 to 25. Like, how does that affect the curve? Or interest rates drop to 0. We can see very quickly, and we can play around with with this function in a nice interactive way. So there's more than just adding functions though, although that's like what I would say that's probably the biggest part of what people use Excel add-ins for, is building out tools of whole toolkits of stuff in this way. So rather than just one function, it might be a suite of functions for different derivatives, or functions for querying databases, for pulling out reports to use, and pulling out reports of data to include in dashboards, this kind of things. But we can also use some of the things that we saw earlier about automating Excel, but now directly from Excel. So I have the same code that I was using before, using in the conf4j example. So here I've got a write trade blotter and read trade blotter, again using the conf4j classes. Here it's slightly different in that I'm using to get the application rather than using it from a hard-coded CLS ID like I had before. Here I'm using this Jinx package to get the application object, so there's a bit more integration there. But you may have noticed in Excel, I had this Jinx thing here, and at the moment there's nothing in here really, just reloading and log file and about and all this kind of stuff. But we can control this whole ribbon. So we can build out controls to our user interface directly in Excel. And that's done just by a simple XML file which describes what that ribbon should look like. So in this example XML file here, what was commented out here is a new group of tools just called trading tools with my create booker, create blotter, and book trade things here. And these have an on-action attribute, and these correspond to here in the same way I used that Excel function annotation to mark a method as being an Excel function. Here I've got an Excel action annotation to mark these things as being an action that can be called from the ribbon. So if I rebuild this again now, again, the only change I've made is just to this ribbon XML where I've uncommented these. If I now go and reload this, now without even restarting Excel, I've got these new tools here. So if I create a new sheet, I can now press the create blotter thing. And again, this is the same as what I had before, but now just running entirely in Excel, so the user doesn't have to go out somewhere else. And put these in again. And then book trades, exactly the same as what we saw before. So now we've got this, this kind of imaginary trade blotter application where before we had it as a separate application talking to Excel. Now we've got the whole thing integrated into Excel, and we're really using Excel as just our front end. So all of our Java code is in the back end, but we're using Excel as a front end in the same way that we would have used like the web app or the desktop app before. One final thing I want to show you, since we have time, is back in the Black Scholes example. If I just bring that up again, yeah, this will do. I mentioned earlier that we could pass Java objects between Excel functions. So I just want to kind of expand on that a little bit now. And this is really useful where if you've got something which doesn't naturally fit into what you can show in Excel. So for example, I don't know, you might have like a database connection object, or you might have some complex structure which you don't necessarily want to expand out into lots of cells. Or you may have loaded some data from a database or whatever, and you might have several million rows, and you don't necessarily want to expand several million rows directly into Excel. You just want to have it as like conceptually just like an object in Excel that you can then perform more operations on. So to kind of demonstrate that now, what I've got is in this Black Scholes example, I've got a simple market data object. So this would be, and again, apologies for keep using the sort of finance examples, but what this is representing is some data that's loaded from a database, which contains a whole bunch of things like stock prices, volatilities, all the market data that you'd need to price a portfolio of options. And here I've got this function just mocking it up with, I'm not loading anything here. I'm just got some data hard coded. But I just want to show you what happens when I call this function that's returning this market data into load market data. What it does is returns me just a single cell, but with this handle. And this handle is really what represents the underlying Java object. And it's that handle that we can pass through to other Java methods, and then this Java object will get passed through. So in the same way that I called the Black Scholes function here, I've now got this Black Scholes 2 function, which is the same. You can see here it's actually calling the Black Scholes method, but it's getting a few of the inputs from this market data interface. So if I call this now, yeah, I've got a breakpoint set, so we'll see what happens. So Black-Scholes 2 takes market data, ticker was, actually let me just, so the ticker's XYZ, and it takes a strike price, so 200, years to expiry, and say it's a call option. So Black-Scholes 2 takes market data, this, and when it calls into our Java method here, you'll see that this market data object is no longer just the handle here. It's actually this object that we returned from this method. So using this, we can actually make our spreadsheets much, much simpler by encoding or by sort of holding a lot more information in a single cell. So we don't need to have loads and loads of sheets with, you know, everything exploded. We can have things that are conceptually like a lot simpler. So if I run this, you'll see, yeah, get through the same thing. Still calling our Black-Scholes thing, but now with this extra data. The final thing I wanted to show you is because, you know, we started off by talking about how can we produce tools which are more useful to our end users. Here we've got this tool here, but as you saw when I typed it in, it's just saying like arg1, arg2, so that's not particularly friendly. And similarly, if we go into here, oops, you know, these things aren't particularly friendly. Like the user's not going to know what all these things are supposed to be. So actually, if I go back into this first function that I wrote, as well as this Excel function annotation, we can also add the Excel arguments annotation, and here give this some extra information. Here I'm just going to give them the names. Oops, excuse me. But with a bit more annotation, we can run this again. Now when we call our Java test method, we should see, you know, now we get much more information coming through here, and we can also give it, you know, documentation for each parameter and a description for the whole function. So again, you can see in here, you know, now we can actually give the user a much better experience and give them this kind of documentation as they're calling the function. Back to this here. So just to kind of recap on what we've seen and what I want you to remember. First of all, developing for Excel is not painful. If you've been stung by writing lots of VBA before and you know just how horrible that is, or you've been caught out by spreadsheets that have been, you know, sent emailed between users and end up with having very slightly different bits of VBA between what different users are seeing, then, you know, that's not what we're talking about. Really, we can just think of Excel as another front end for our Java code. So our Java code sitting there, well tested, in version control, centrally deployed, that kind of thing. But really, we're just using Excel as a front end in the same way that we would write a web app, that kind of thing. We can also use Apache Poi, as we saw, for static reports. So if you're ever in a situation where you need to write out some CSV files or dump some data for a user, then just consider using Apache Poi to make the report slightly nicer. If you already have a desktop application, but you need some kind of interaction with Excel, if, you know, rather than dumping out an Excel file, then just think maybe there's a way that you can automate Excel from Java, and you can do that using Conf4j. And then finally, you know, really the most integrated solution is to have your Java code running inside of Excel as a Java add-in, and we can do that using Jinx. So as I said at the beginning, all of the source code's available. Just go to Excel Java on GitHub, and you'll find this Excel Java talk, and all the code's available there. The website I showed you was exceljava.com, and, you know, please do feel free to reach out. It's just Tony@exceljava.com. You know, I'd love to hear what you thought of the talk and if it was interesting or useful. So yeah, and I think we should have some time for some questions now, I believe. So let me come out of this and back to the back to this thing. Let me stop sharing. And okay, cool. So if anyone's got any question, then please, I'm happy to answer any questions you've got now. Oh, apparently there's no questions. Just say hi in the chat. You know, any if there's any comments, then feel free to write something in there. But otherwise, oh, apparently there's a bit of a delay. Absolute silence from the room. Okay, so I don't know. Ishkan, can we bring people online for questions, or do you just want me to answer them as they come into the chat? While we're waiting for questions to come through. Okay, so Todor, you had a question. If you just type your question into the chat, then I'll repeat it and then I'll answer it for you. While we're doing this, I'll copy the website into the thing as well. So you got a record of it there, and then
Santam has a question in the questions tab about any thoughts about integration with Google Sheets.
Okay, great. Yeah, so Google Sheets is an interesting one. They don't really have, because it's all running online, they don't really have a way to integrate with Java code at the moment. The way the Jinx add-in works is using the XLC API, and it's done that way like purely for performance. So it's you know, it's possible to have really kind of millions of calculations in Excel at once, and having the JVM embedded inside of Excel is the only way to get the performance needed to do that. So Google Sheets, you can write functions in JavaScript, which will run in the browser, but there's no way to kind of embed like the full JVM and everything you need to connect to your backend systems, like all the databases and message buses and things like that, in the browser that way. So you'd have to write it as, you know, a client server type thing using JavaScript. So there's also saying, is it possible to use it in LibreOffice? And I think there are toolkits for using for creating add-ins that really, when you're dealing with end users, particularly in the larger enterprises, it's kind of Excel or nothing. Like if you here's just, you know, Excel just has a much wider user base, so it really makes more sense to meet the users using the tools that they use, and in 99.9% of cases that's actually Excel, particularly in, I guess, my background, because it's finance, where people are using Bloomberg and Reuters and all those kind of things, and those have Excel add-ins, so Excel is what those people use. Yavor says that the trial period is very short for a Java novice. Well, that's true. It's a 30-day trial period, but then it's actually free to use after that. So it's free to use for some sort of limited functionality. But also, you know, just contact me if you're having trouble, and you know that trial can be extended very easily. It's no problem.
Deva Balan has a question. Will this support Mac Excel as well?
Yeah, so Mac is an interesting one because of the way Microsoft actually develop Excel. They have the C API and the COM APIs we saw, but both of those are only available for Excel for Windows. The Mac version is much more closed down. It doesn't support a lot of the features that are in the Windows version. So if Microsoft were to add a way to extend Excel for Mac, then it would be possible for tools like Jinx to use that. But currently, the Mac version of Excel is just much more limited. And again, like what I was saying with LibreOffice and stuff, is that what you tend to see so it's a very small user base, really. It's I mean, I understand from a home user point of view, things like LibreOffice and the Mac version of Excel are attractive because especially developers are using Macs, but it's really not what sort of businesses are using.
I think these were all the questions for now.
Perfect.
Thank you, Tony.
Okay, thanks everyone for your time and thanks for listening. And again, like, please do get in touch with any other questions and yeah.